In this video, I would like to focus on solving simultaneous equations by elimination, but in situations when we do not have the same coefficients. So we will have to do something to one equation or both equations to get the same coefficient to be able to eliminate the second variable. So in this case, we have coefficient x is 2, coefficient x is equal 1. Here with y, we have 3 and 2. So we can simply notice that we have coefficient equal 1 here. So if we will multiply 1x by 2, we will get exactly the same coefficient as here. So I will multiply full equation, both sides, by 2. So the first equation I will copy without a change. So it will be 2x plus 3y is equal 17. And the second one, I will multiply the full equation by 2. So x times 2 will be 2x, 2y times 2 will be 4y, and 10 times 2 will be equal 20. Okay, so if I have the same coefficient, I can add or subtract both equations. So thus, different signs, adding, same signs, subtracting. We have same signs, so we will be subtracting those equations. So 2x plus 3y, take away 2x, and be really careful, we are taking away full expression, so we also need to change sign here, so it will be take away 4y. If you're not sure about the signs, you can always use the bracket and write down this full expression in the bracket. Then you will be able to change the signs and probably will do not any mistakes. 17 take away 20 will be negative 3. Okay, so we will collect like terms. 2x take away 2x. We will eliminate from our equation, and we will have 3y take away 4y is equal negative y, and it must be equal to negative 3. Remember, we need to have y, not negative y, so it means that we need to multiply both equations by negative 1, and we will get y is equal to 3. So we have our y. The next step is to substitute this value to any of those two equations. So we can use any of these four actually equations, so three equations. So we can use those two before the change, or also this one when we have changed and multiplied by 2. But it would be actually pointless. So I will substitute to my original equation. So original equation was x plus 2y is equal 10. So x plus 2 times 3 must be equal to 10. So x plus 6 is equal to 10. So I need to subtract 6 from both sides to balance the equation, and I will get x is equal 10 take away 6, 4. So x equal 4 and y equal 3 will be the solution of our simultaneous equation. The second example I would like to show you is a little bit more difficult, because if you will look at the coefficients with our variables, we will have 3 and 7 and 5 and 2. So if we will multiply only one equation, we will never get the same coefficients. So we will have to do something, multiply both equations to get the same coefficient. If we look at number 5 and 2, so the common factor will be 10. The common multiple, sorry, will be 10. So 5, to get 10, we need to multiply by 2. And from 2 to get to 10, we need to multiply by 5. So we are multiplying both equations by a number to get the same coefficient. So 3x times 2 is equal 6x. 5y times 2 is equal 10y. And negative 4 times 2 is equal negative 8. Second equation, 7 7x times 5 will be equal 35x. Minus 2y times 5 will be minus 10y. And 18 times 5 will be equal 90. So we have the same coefficient, different sign. So according to das, different signs we are adding. So we will add it here. So 3x plus 35 will be equal 41x. 10y, take away 10y will be equal 0. So we'll cancel it out and we'll eliminate y. Must be equal to minus 8 plus 90 will be 82. So right now we need to divide both sides by 41. So x will be equal 2. When we have found x, we need to substitute this x to one of this equation. So I will choose the first one. 3x plus 5y will be equal negative 4. So I will substitute x equal 2. So it will be 3 times 2 plus 5y is equal negative 4. So 6 plus 5y is equal negative 4. I will subtract 6 from both sides to balance the equation. So I will get 5y is equal negative 6, take away 6, it will be negative 10. So by dividing both sides by 5, I will get answer y is equal negative 2. So x equal 2, y equal negative 2 is the solution of our pair of simultaneous equations.